Hey folks, so in this video I want to talk about how objects are represented in Java. Now the representation is actually going to be a little bit different than maybe what you'd expect. So in the past you've used things like primitive types, for example doubles, integer, char, that type of thing. Now when you create a variable like that, what you're doing is basically just making a variable that stores that piece of data directly. No problem, okay? And I can even jump down here to my picture for a second to illustrate that. So here notice I have a very simple variable, int value equal 5. And what that corresponds to is that there is some place in memory where that 5 is stored. And I'm illustrating that here with an arrow, right? So that variable, right, goes straight to memory, right, stores the thing right there. And that's very intuitive, right? And that's typically how people think about, variables working, right? They store the thing that, I put in them, right? Makes sense. Now, the unfortunate bit here is that objects in Java do not work this way. What we just talked about a second ago where it directly stores it is only applicable to primitive types. Things like an object, though, aren't primitive types. They're what we call reference types. So reference types work a little bit different. Well, okay, a lot bit different. A reference type is basically a type where instead of storing the value that you put into it, it's going to store an address in memory where that thing is actually available. So looking back down at our diagram, here I've created an object, right? So this is a more complex thing. It's not a primitive type. And you can kind of, the hint here, right, is that something is different is I have to use the new keyword. The new keyword stands for memory allocation. You're asking the system for, I need more memory. And what you're doing here, right, is basically you're creating this new variable called C1, and you're storing into it an instance of this new, a new instance, right, of this class called counter, where in the constructor I pass along the word first. Point is, right, I built a new object, right, in an instance of this class, and I'm trying, right, in my code here to store that new object, right, into that C1 variable. But, right, it's a reference type, so things are a little bit, different, right? Than they were for primitive types. And in actuality, right, what we're going to store there is the address. So if you look at your picture right here on the right hand side, what you'll notice is that our little arrow here, right, which is kind of denoting what is the information is stored inside this variable, that's actually storing this over here, x04. Now x04 clearly isn't our object, right? That string first is nowhere to be seen. So what is it? Well, look at the diagram. x04 is basically the address in hex of where to go in memory to actually find this stuff. So I have drawn this other arrow here, right, which basically says, jump down here. So somehow we're introducing a level of indirection. So we're not storing the thing directly, we're storing the address of where I could find it, okay? So this is a little bit different, right? So these are called references, right? These are reference types. And there is significance behind here. This actually gives us some performance advantages. Note that this is related to the idea of a pointer. So when you guys go to kind of different classes, right, you will see, you learn a language called C or C++, and in these languages we have something called pointer types, which are basically going to be the same thing as reference types, except that we have to manually do it. There's actually some notation. We add things like stars and whatnot, and we mark things as a pointer. Right now, everything just kind of happens automatically for us. Whenever we have an object, that variable automatically treated as a reference. It'll then store, right, the address of something rather than the thing itself. All right, so this is kind of our idea here for reference types. Now, reference types are nice from the standpoint of performance. They're nice. Well, so they're nice in terms of performance because you can basically copy variables around, and it's very cheap, right? We'll somehow see this a little bit in a couple slides. Actually, I want to talk through some other stuff before maybe have that discussion. But one thing here, right, and the reason why we're actually talking about it in this course is because it could be a little bit problematic, and we'll see why in the next slide. So, well, okay, not that this is the next slide, but we're not actually going to do that just yet because I need some background before we can talk about why it's problematic. So what I want to actually do, right, is I want to work through an example where we have some different reference types being used and then try to trace the output. So that's where we're going to be going in a second. Now, before we get there, we have, of course, this counter class. And I want to talk about this because we'll need to use it in our example. So our counter class is reasonably straightforward. I think it's reasonably straightforward. So we have just two things inside it. We have a name and a count. Basically, we have some sort of a title for a counter and then a count on it. Now, what is this counter class? This counter class is basically just like, think of it as being like those little clicking things, right? So it's like you go to a show, right, and they're counting the number of people in the audience, right? They have this thing and they just click, right? And basically they're just counting up, how many people are there, right? Their counter presumably starts at 0, and they hit it every time they see a person. That's basically what we're modeling here, is a counter. Now, it does have the extra feature on here, right, where we have a name on it because, well, it makes it easier for us to tell them apart. So yeah, that's what we got here. We have a pretty standard constructor, right? Constructor just states up the name. Count was already initialized to 0 over here, so that it's fine. And then we have our increment button, right, to click it, and then our tally button to glance at and see how many times you've clicked it, and then a nice little toString, which basically lets us see what does it say this thing, right? So it's like this clicker with this name has been clicked this number of times. So yeah, not that complicated. This is our clicker class, our counter class. And so what we're going to do is basically trace some code that uses this. All right, so here are a couple of examples. So on the left-hand side, I have a main method. So this is going to be pretty straightforward code. And let's just read through this line by line. What I want to do is I want to read through this, and then we're going to try to figure out what is going to be the output. All right, so counter C1. Counter C1 equals new counter of first. Okay, that seems legit, right? I just created a new object. Okay, counter 2 equals C1, so all of a sudden I'm doing the assignment, so I'm copying that over. So that should be fine. Then I go C1.increment, C2.increment. So I'm doing an increment on both of those variables that I created. Okay, so good so far. And then at the end here, right, I have a print out, right, print ln on C1 and then C2. And so the question for you guys, and I want you to pause the video and think about this, what will be displayed? What is going to be the value that should be printed out? Okay, so what values get printed out? The values are going to be, well, I'll draw it over here, 2 and 2. Now, some people, when they do this, get something a little bit different. They get 1 and 1. Let's talk about that. So 1 and 1 basically means that, okay, I had my C1 variable, I created a new counter, right? I did, an increment on C1 once, so it should be 1, right? C2 was, it's a copy of C1, it's its own incrementer, so it got clicked once as well, so when I print out, it'll be 1. That's the thought process there. But unfortunately, it doesn't quite work out because we are, in fact, dealing with reference types. So that, it's no good. So let's actually draw a diagram of how this maybe looks in memory. So I probably have, right, basically 2 variables, right? So what I'll do is I'll draw this over here. So I have C1. I'm going to put a box next to it. And the box somehow is representing like that place in memory where that variable lives. So I have basically, this box for C1 and then for C2. There we go. That's a 2. So I have my counter, right? So I have my 2 variables, right? So all of a sudden it's like I'm looking at my program as, this stuff over here. These are variables, so I'm going to start adding them to a diagram here. What I want to basically diagram out is the memory that's being used in this main method. So yeah, I have my counter being created, right? So I have this over here. So somewhere else, right, I have some memory allocation, and here I have the word first. Okay, so I have first there. And then, right, this is where maybe things are a little bit not intuitive, right? Is notice, right, that I basically have first off to the side in another box, right? It's not inside the box next to C1 because C1's a reference type, right? It's storing an object. So actually, it looks like this. I have a little bit of an arrow, right, which says, okay, C1 is storing the address of first, okay? And so then C2, when I do this assignment over here, it's not making a copy of that object. It's making a copy of the address that stores that object. So it's like I'm going to duplicate this arrow here is basically what's happening. So upgrading my picture, it looks like this. I have C1 and C2 both pointing at first. And so when I do those 2 increments, even though I'm doing them in different variables, they're occurring on the exact same object. So I only have 1 object in my system, so it's incremented twice, right? And so I get 2 and 2 back out. A simpler way to see this as well is simply to observe the number of times the new keyword occurs. Here I only have 1 new keyword, right? I only did new once. Therefore, there's only ever 1 object, so all of those increments have to happen on that 1 object. So yeah, that's on the left side. So let's take a look at the right side, which is a little bit different example. And again, I'll trace through it, and then we'll see what the output is. So I have my main method, right? So that's where I'm going to start. Difference here is now I'm introducing another function. So I'm introducing a foobar function just to make things a little bit more interesting. So I have my main. My main, right, I basically create a counter. So this is the same as the previous one. And then I go C1.increment, so click it once. Then I call foobar on C1. Okay, so foobar, all of a sudden, right, C1 goes away, right? So C1 does not exist, right, in that name over here, right? It's a little bit different because I'm doing a function call. So I go to foobar, and at the end I print it out, right? So this is one place I'm wondering about, what is the output going to be? Looking at foobar, foobar looks pretty straightforward. I have a counter coming in as a parameter, and then it's called C, and then I go, C.increment, right, to click it. And then I print out the whatever is the number it's on it. So the question for you guys, right, is what is the value it's going to be displayed at each of these points? So pause the video, figure it out, and then we'll talk about it. All right. So hopefully you guys worked through that, and I think probably you guys have gotten the result, which is 2 and 2. So this somehow, right, has kind of the flavor of the previous example, right? We can observe, for example, right, that there's only 1 new statement. So that means there's only going to be that object. It was only ever created once. Now the kind of red herring here, right, is the fact that we have a function call, right? Now a function call, right? A function call basically is introducing a new variable, right? So if I look in here, right, there's this counter to C thing. C somehow is a new variable, right? That wasn't in our other code. But that C variable, again, that type on it is counter, so it's a reference type. So C is basically another variable, right, which stores the address of, the address that C1 stored, right? And that happens to be the address of the object, right, that we created. So again, right, if we have basically the same picture, right, we could draw basically the same picture, right? So we could have C1, right, looking at first. And then it's like, well, I do a function call, right, over here, right, and this is now called C. And when I do my function call, right, I'm doing foobar of C1, so C1 is getting passed as a parameter. Copy of C1 gets made into C. Well, C1 really is just storing that address of first, so now C is storing the address of first as well. So we do an increment, right, and then we do our print, right? We do the print twice, right, once in the foobar, once in the main. Both of them look at the same object, so I print out the same thing, right? The result of that same object, which is going to be 2. So 2 and 2. So this is basically, right, what we have to worry about when we have objects in Java, right? We have this kind of reference behavior where I can pass around references. Now all of a sudden, right, I changed my wording there a little bit. I said worry. Up until now, right, I've just been observing behavior. So why might I worry about this? I'm going to worry about this because basically, right, you can imagine, right, is that if I pass around objects in my system, somebody might do something bad, right? So what if foobar wasn't supposed to increment counter? What if I was giving foobar counter purely for the reason of, oh, it needs to look up the counter, it needs to look up the tally, so we can print it out or something else, right? What if that was the way it was? Well, here, I don't have anything. I don't have any safety, right? The instant I pass an object to another function, right, or pass it anywhere in my program, or via another variable name, anybody that has a reference to it can change the original. Right? So this is bad, right? So it's like, well, I have this one object, right, that I've created. It's very special to me. Right? I don't want anybody to tinker with it. But if I want anybody else to pull information from it, I need to give them that reference, and all of a sudden they have full rights to change stuff in it. So this is absolutely horrible, right? We don't want this to happen, right? So these lead to what we call referential issues, right? So I'm passing around some sort of reference, and all of a sudden people are using it in an incorrect way that corrupts the original object, right? So this is a huge issue. So we are going to actually talk about a way basically to address this. We're going to do it later on in this module. I'm going to introduce the idea of an immutable type. So a mutable type is basically an object in Java, but it's been designed so that nobody can change the contents of it. Once you do that, you can basically pass around something freely, and you know that, hey, if this is an object that can't be changed, well, then nobody else is going to ever break it, right? So in that case, right, life is good, right? We don't have to worry about any kind of bugs from referential issues. All right. So hopefully after this video, you guys have a good sense of what are reference types, right? So objects are reference types in Java, and then also referential issues, right? The issue of passing something around, and basically anybody's allowed to change it. So I will see you guys in the next video.